Hello, everyone. Welcome back. Today, we're going to go over section 2.9, which is applications in business and economics topics, applications of the derivative specifically. In section 1.3, you might recall that we discussed how to build functions like C, which represented a cost function, and R, which represented revenue, and P, which represented profit. Now, this is, traditional business applications. Cost is the cost to the manufacturer. R is the revenue gained by selling your goods if you're a business. And P is the profit that you get off the top. Profit is always given by the revenue function minus the cost function. And so section 1.3, you had some practice with building these types of functions. Well, we're going to come back and revisit these, not only to remind ourselves how to construct them, but also to discuss them in the terms of the derivative now that we know how to find it. So what we're going to associate with the derivative for these applications is the term marginal. Marginal is a word in business and economics to indicate a rate of change of these functions with respect to x. And since it involves a rate of change, that means it indicates a derivative. So marginal, you should think of, is an alternative word for the derivative. So if I say find the marginal cost, that means find the derivative of cost. If I say find the marginal revenue, that's the derivative of revenue. Now, marginal in front of all these terms does mean the derivative. They each have their own little meanings and definitions that I have written here. Now I have the definitions here and my own little interpretation written down underneath them. Marginal cost is represented by C prime, right? Since C is regular cost. Marginal cost is an estimate of how the cost to the manufacturer changes per unit increase. That means the change in cost that comes from producing one more unit or item. Marginal revenue, marginal again means derivative, that means derivative of revenue, is represented by R prime. And marginal revenue is an estimate of how the revenue changes per unit increase, or that is from producing one more unit or item. Marginal profit is represented by P prime. Again, marginal just means derivative of profit. And so marginal profit in words means an estimate of how the profit changes per unit increase. That is when producing one more unit or item, whatever it is you're manufacturing. Now there is a new function that we're going to discuss that was not talked about in section 1.3, and that is average cost. Average cost, they have on the next page, is denoted by C bar, and it's a new function that you get by taking the original cost function and dividing by x. So we're going to do a couple of examples of finding the average cost. And of course, if we have average cost, we also have marginal average cost, which just means the derivative of average cost. So if average cost is C bar, marginal average cost is C bar prime. And they have that written over here at the top of the next page. C bar is C of x divided by x. So let's start the practice problems where we remind ourselves how to build some of these functions and then throwing in terms marginal every so often to make us have to find the derivative. Let's start with number 1. A vendor charges P, that's a price, to 22.5 plus 0.5x for a certain commodity. What is the revenue function? So the most important thing is to read the last line because it tells you what are you trying to find. It says, what is the revenue function? Now, it's not saying what is the marginal revenue function. It's just asking what is the revenue function. This is telling you to find, or that is build, just revenue. Now, this is a question that's not new in form. You would have learned how to build revenue function in section 1.3. So this question is just a jog your memory type of question. We're not doing derivatives here. It's not asking for it. It's just asking for the revenue function, not the marginal revenue function. Now, revenue, we have to build it. Revenue is kind of given by this template. It means to find revenue, you always have to multiply the price of the items that you are selling times the number of items. Now, these phrases can be represented by different things and different formulas, but the number of items here we're taking to be X. X is, they just didn't say what it was, they just said a certain commodity, but X is the number of items. And so at least we know the number of items in our formula is going to be represented by X over here. Going to be multiplying by X. So then that leaves us with trying to figure out what is the price. Now, they didn't say the price was something flat. They didn't say the price was $20 per item, and then I could just write in 20. What they did say that our price, or that is the demand, is given by this formula. So instead of writing a flat number in for the price, I have this expression that I'm going to be writing in for the price. That's what the demand means, it's the price. And as most things do, price tends to fluctuate. So it actually makes more sense for the price to be represented by a function, in most cases, than just a flat number. Anyhow, this is price times the number of items, and this will be my revenue function. Now we can't just leave it like this. We got to make it look pretty. Let's take this X here and distribute it in, multiply, so we can simplify it. This gives an expression, 22.5x plus 0.5x squared, when you multiply x times that term and x times that term. And so we get our revenue function here, and they're not asking me to do anything with it. They just said find the function itself. If they had said find the revenue for 20 items, this is when I would plug in x, but they didn't ask me to plug anything in. They just said find the function itself. So we're done here. Move on to number 2. A supplier of t-shirts charges vendors for each order based on a setup fee of $50 and an item charge of $1.15 per t-shirt. What is the cost function for the vendor? Oh, as always, look at what they're asking you to find. It says, what is the cost function? They didn't say what is the marginal cost function, which we would take to mean the derivative. They just said find the cost function. So this is, again, just find an original function, C. I don't have to do anything with it. I don't have to take the derivative of it. If they wanted me to take the derivative of it, they would have said find the marginal cost. So all I have to do here is build C, which is, again, something that we would have learned in section 1.3, but we're revisiting it here, just to remind ourselves how to do it. Now, the general formula for building a cost function, now remember, this is manufacturer cost. This is how much that it's taking you as a vendor to produce your t-shirts. Now, cost is given by the manufacturer price, the manufacturer cost, how much it is costing you to build your or make your t-shirts, times the number of items. In this case, it'd be number of t-shirts. And then off to the side, you might have to add any fixed charges. So fixed charges can be anything from rent or electricity or something that has generally a flat and even cost that doesn't fluctuate much. So a cost function is the price per item it takes to manufacture your t-shirts times the number of t-shirts you're making plus any fixed charges that might appear. Now let's read it again. How much is it costing the manufacturer to make their t-shirts? It looks like we have an item charge of $1.15 per t-shirt. So we have $1.15 is our manufacturing price times the number of items, which in this case represents t-shirts, and we're letting X represent the number of items. So this is manufacturer price times the number of t-shirts plus any fixed charges. Now, do I have any flat fees. It looks like I have a setup fee of $50. So I add that here. This is a flat value that I'm being charged. So we have now built the cost function, the manufacturer cost function. They didn't tell me to find the costs after producing, say, 100 t-shirts. If that's the case, you would just plug in your X. They just said find the function itself, and we did. There it is. We're done. Moving on to number 3. Let's read it. The owner of a craft shop has determined that he can sell X purses. So I'm going to make a list. So X represents the number of purses. And we have price P. It's also called the demand. That's why they call it D there. Price or demand is 46 plus 0.25x dollars. That's the price of our purses given as a function. The total cost for these purses is given by C here, and they give me a formula. So remember, this is the manufacturing cost. This isn't the cost to the consumer. This is how much it's costing this craft shop to produce these purses. And what does it want me to do? It says find the marginal profit function. So when we read this, we've got to pull out what is it asking me to do. Like the bottom line, end result, what do they want? It says find the marginal profit function. Marginal is our key word here that's supposed to be new to this section. Marginal means the derivative. So that means they want me to find the derivative of the profit function. So there's two things that I have to find. I have to first find the profit function, so I can then take the derivative of it. Derivative of profit. That's what they want. So if I'm going to build profit to take the derivative of it, we have to remember how to build P. P is our profit function, and it's always written as revenue minus cost. So let's take inventory of what we have here and what we don't have. Do we have a cost function? We do. It's right there. They gave it to us. That's nice. But what we don't have is revenue. What we have here is price, which is close, but not quite. So before we can find profit, we've got to find revenue, so I can find revenue minus cost. And so let's break this down into pieces. First, let's find the revenue function, because it's part of my profit equation that I'm trying to find. Now, revenue is always the price that we're selling our objects for times the number of items. Now, price in this case is given by the demand. It says the price is given by P. So we put in that formula here, 46 plus 0.25x for our price. And the number of items is given by X. They said we had X purses, so we write in X here. Now, revenue is this formula, but let's clean it up here like we did last time and multiply this X through to both of those terms. That would give me 46 times X plus 0.25x squared. That's my revenue function. Now, of course, I'm not done. This is a part of a bigger problem here. What I ultimately want to find is marginal profit. And profit is revenue minus cost. So I come over here, we'll make this part 2. I need to find profit. I've got to plug in revenue, which now we found, and subtract cost, which actually they gave us. So let's be careful here and deliberate and write it in. We have revenue minus cost. Now, I always put parentheses around the things that you're subtracting because you will ultimately have to distribute the minus sign, and it's easier to remember if you put parentheses around like anything you add, subtract. So we have revenue minus the cost function they gave us. when I finish subtracting these two, I'm going to have my profit function. So let's be careful here and subtract. And when you subtract, and this is why I like to put parentheses around everything, this minus sign gets distributed to every term in the function that I'm subtracting. So every sign here changes. This will be 46x plus 0.25x squared minus 0.15x squared minus 6x minus 190. And this is, of course, my profit that I'm finding. Now we're almost there. We don't want to leave it quite this long. I do see I have some like terms here, so let's look at that. I've got 0.25x squared minus 0.15x squared. Those subtract to give me, so 0.25 minus 0.15 is 0.10x squared. And then I have 46x minus 6x. Those are like terms. So that becomes 40x. And then I have minus 190 left over. Okay, so here's my profit function. We found it finally. And the question of the day is, are we finally done? And the answer here is not quite. We did find the profit function, but that's only part of what I need to get to. I need to find the marginal profit function, which means now that I've got the profit, I need to take the derivative of the profit. So we'll make that step 3. Now that we have the profit function, let's take the derivative of it. P prime of x, we have a power rule there, 0.10 times 2 is 0.20, x to the 2 minus 1, derivative of 40x is 40, and the derivative of negative 190 is 0. So this is my marginal profit function. Now, they didn't ask me to plug anything in. They didn't say find the marginal profit at x equal 2 or something like that. So I don't have to plug anything in. All they want is the function itself. And so we get the marginal profit, the derivative of profit, and we're done. Let's start number 4 here. It's pretty similar, actually. It says, suppose that a manufacturer has determined that the price of producing X units of a commodity is given by P. So I have price again. And it says the total cost is given by C. And so this is our cost, our manufacturing cost again. It says determine the marginal profit for selling 16 units. Now this one, when you read the last line, it's telling me to find the marginal profit again, which means find the derivative of profit, which is very similar to what we did above. There's only a very slight difference between this one and the last one. This one, they say, find the marginal profit for selling 16 units. Now they want me to actually plug in a value here. That means that once I find the derivative of profit, the marginal profit, we'll have to plug in 16. So let's make a note of that. I want to find the derivative of profit and then plug in 16. So I'll have to do one more step that I didn't do in the last line. Last line I stopped at marginal profit. This time we'll have to just plug in a number once we get there. But all the rest of the steps are actually quite similar. If I'm going to find the marginal profit, I first need the profit. So if I'm going to find the profit, revenue minus cost, I need to know, like, what do I have? Do I have the revenue? Do I have the cost? Did they give those to me? They did give me the cost. It's right there. But they did not give me the revenue. They gave me the price. So I have to first find the revenue function in order to be able to subtract revenue minus cost. First, find the revenue. Now, revenue is always price times the number of items. And they're once again letting X represent the number of items or the units, and price is given by this fluctuating equation. When you distribute this X in, just like we did the last couple of times, you get 117x minus 0.25x squared. You're multiplying the x to both of those terms in the parentheses. Our second step now is to then find the profit. Now that I have the revenue function, I can subtract revenue minus cost, which they gave me, the cost. Revenue, I copy down this formula, 117x minus 0.25x squared, and I'm subtracting the cost function, which they gave me right here. Make sure you put parentheses around it, because we're going to be distributing the minus sign. So P of x is 117x minus 0.25x squared. This minus sign gets distributed to both of those terms. This becomes negative 225 minus 2x squared. Collect any like terms if there are any. Let's see, I have negative 0.25x minus 2x. So this gives me negative 2.25x squared. And it doesn't look like I have any other like terms. I only have one x term and one constant term, so I'm going to copy those down. And then I have my profit function. If they had asked for the profit function, we'd be done, but this time they want the marginal profit. So I have to find the marginal profit, which means that we have to take the derivative of the profit function now that we've got it. So P prime of x, the marginal profit, is, so I have a power rule here, negative 2.25 times 2 is negative 4.5, x to the 2 minus 1. The derivative of 117x is 117, and the derivative of negative 225 is 0. So this is my marginal profit. Marginal profit function. We're almost there, almost there. We had to get the marginal profit function, but I'm supposed to find the marginal profit for selling 16 items. So now that I've got the marginal profit finally to be done, we're going to plug in x equals 16 into P prime, the marginal profit. So I get negative 4.5 times 16 plus 117. Now for this, I'll have to get out my calculator here. And it looks like I get 45. So the marginal profit for selling the 16th unit is $45 at the 16th unit. Now let's look at number 5. This is the total cost of producing X clock radios is given by the function C. Now this is manufacturing cost of production, and it looks like X is the number of clock radios we're manufacturing. It says find the marginal average cost if X equals 4. So when we look at this, I do see the word marginal, which means to me derivative now. They want me to take the derivative of what? They said the derivative of, and here's another keyword I've got to look, I have to notice, average cost. Find the marginal average cost. Now, average cost is that new function that I introduced at the beginning. This is C bar. C bar is a new function that we have to build. So if it had said find the marginal cost, then you'd take the derivative of C. They snuck in this word average here, indicating we're going to have to take the derivative of C bar. Now, if you recall from the front page, the average cost C bar is given by the cost function, which we have given here, where you divide it by x. So you have to, in order to do this problem, we first have to find the average cost function because they didn't give me average cost, they gave me the cost. I have to find the average cost function, C bar, and then I have to take the derivative of it. It says find the marginal average cost if x is equal to 4. So we have a nice process here. It says find the average cost, C bar, build it, then take the derivative, and since they're giving you an x value, that means they want you to plug it in. So build the average cost, take the derivative of it, plug in 4. That's going to be our process here. So step 1, find C bar. Now, when you are doing this, you have to take your function C. I'm going to start over here off on the side. C bar is given by your function C. This whole entire thing is going to be divided by x, the number of items. So your cost function, 300 plus 24x, the whole thing is going to be in the numerator of this fraction, all divided by x. Now what that means algebraically is that every single term in C is divided by x. You'll have 300 divided by x, 24x divided by x, this divided by x, that divided by x. So you have each one of these terms is divided by x. So what I'm going to do here is do that and split it up. We have 300 over x plus 24x over x minus 0.4x squared over x plus 0.1 x cubed over x. That's what this will equal. Now let's simplify some x's down. I have some laws of exponents to take care of here. Now 300 over x, that stays how it is. It's not going to reduce down any. But 24x divided by x, these x's will actually cancel each other. That leaves me with 24. X squared divided by x is x. That becomes 0.4x. And x cubed divided by x is x squared. This is now my C bar. And it's as simplified as it's going to get. It's a new 4-term expression here. So this was cost. Now this is average cost. Averaging it over all of the items x. This is its expression. Now part 2 is, remember what we're trying to do here, we had to find the average cost, then we have to find the marginal average cost, which means we need to take the derivative of this thing. Find the marginal average cost. Take the derivative. Now this thing, when I'm looking at it, I'm about to take the derivative of it. These terms look kind of nice. Now 300 over x, this one's a little peculiar. We need to change up my C bar and make it look a more derivative friendly, in a more derivative friendly format. So I'm not taking the derivative yet, but what I am going to do is I'm going to take my C bar that I'm getting ready to take the derivative of, and I'm going to take this term and pop this x up into the numerator, make the power positive, or make the power negative. It becomes x to the negative 1 in the top. This is because I really want to do a power rule on this, and whenever you have x in the bottom of a fraction, you're supposed to push them up to the top and make the power negative. So I haven't taken the derivative yet. I'm about to. I just needed to change this a little bit so that it was better for trying to take the derivative of it. Now let's take the derivative. Each term. So I've got c bar prime. This is going to be a power rule. 300 times -1 is -300. X to the -1 minus 1 is -2. The derivative of 24 is 0. You don't have to write that, but I'll write it here for emphasis. The derivative of -0.4x is -0.4. And the derivative of 0.1x squared, that's another power rule. 0.1 times 2 is 0.2. This is x to the 2 minus 1. There's a plus in there in between those terms. So this is c bar prime. This is the marginal average cost. Now let me clean this up a little bit. I kind of had to cram these two terms together right here. This is -300x to the -2. Now that I'm done taking the derivative, you don't have to take the derivative again. But I would like to, now that I'm done taking the derivative, take this negative power and kind of put it back down in the denominator. This is -300 over x squared plus 0, so I won't write it, minus 0.4 plus 0.2x. This is my marginal average cost. Now that we've done that, the next question is, are we done? And the answer to that as of right now is not yet. Not yet. We're not quite done. So I was supposed to find the average cost, find the derivative of average cost, and then now I've got to plug in 4. We want the marginal average cost if x is 4 items. So now I have to plug x equal 4 into this derivative, c bar prime, the marginal average cost. Let's do that. I get -300, so I'm plugging it in here, right there. -300 over 4 squared minus 0.4 plus 0.2x, which is 4. I get -300 over 16 minus 0.4 plus 0.8. Let's punch this on our calculator, see what happens here. -300 divided by 16 minus 0.4 plus 0.2 times 4. And I get -18.35. So we find that the marginal average cost at x equal 4 items is -18.35. So what is the significance of a negative average cost? That means that my average cost is actually going down, which is good when you're a manufacturer. You want your costs to go down. So the minus sign does have a meaning. It's not something that is odd. Negative sign means the cost is going down. And in particular, the average cost is going down. That's good. And so all of this all together means that for producing the fourth item, the average cost is going down by $18.35 or $18.35. And when you look at these problems, sometimes they're multiple step like this. All it takes is a series of three or four words to make it a little bit longer. So figure out what they're asking you to find. If they throw in the word marginal, that means derivative. Derivative of what? In this case, it was average cost, which they didn't give me the average cost. So don't take the derivative of that. That's the marginal cost. first find the average cost function, which means you have to divide every term by x and simplify. Then you take the derivative of it to get the marginal average cost, and then you plug in your value, in this case 4, to get the marginal average cost for the fourth item. And that is actually it for this section. That's all the practice problems in the homework. See you next time.